Hello, statistics students. Here is another video on modeling linear trends, example 8. Salary and year of employment. The equation for the regression line relating the salary and the year first employed is given above the figure. Report the slope and explain what it means. From the regression equation, the number in front of the predictor start year is our slope, negative 2.099. And what does it mean? Remember, the slope tells us how the predicted value or the response variable changes for an increase of 1 in the predictor or the horizontal value. And so that means that if we start 1 year later, which means another year after, so we get hired 1 year later, that means the salary will decrease by 2.099 measured in thousands of dollars. So that's 2,099. So for every year later we start, the salary is going to decrease by 2,099. Part B, either interpret the intercept, that 4,255 measured in thousands, so that's 4,255,000, or explain why it is not appropriate to interpret the intercept. So the intercept corresponds to when the predictor variable is 0. And so that would correspond to the year 0, 1985, 84, 83, back to 1500s, 1400s, 1300s, 1200s. It doesn't make a whole lot of sense to go back to the 0 year and talk about the salary at the 0th year. Typically, as we'll remark later in subsequent videos, is when you go outside of your data, the reported data from 85 to 2010 there, or maybe 2006, 7, when you go far away from the range of the data, you're using what's called extrapolation to make predictions, and it's typically not valid. Whereas if we go inside the range of data, that's called interpolation, and that's what regression is used for. So the intercept corresponds to year 0, and it doesn't make sense to look at year 0. The data is good for the time frame for which the data was collected, 85 to about 2007 or 8. This is called extrapolation, and generally, extrapolation is useless, as in this case. It goes too far away from the data. And this concludes this video of modeling linear trends, example 8.